I connect directly this point to this point. If we check the input, we should find 220 volts. As you can see in the multimeter, okay? So the VDA, we have 220 volts. This is the capacitor. We have 220 volts, okay? And in this point, 220 volts. In the other terminal, we have 220 volts, means this resistor is good. So then we should, as you can see here, find 220 volts in the anode of the diode. So in the other side, as you can see, oops, we don't have anything. Is that mean this diode is bad? No. Here we should select the continue voltage. We should go here, we should go and select 1000 here, means the continue voltage, because after the diode we have to continue voltage, not alternating voltage, okay? So now we select the continue voltage, as you can see. Now we should find in the diode and in the capacitor 300 volt DC. We have 300, as you can see. If we check the capacitor also, we should find, as you can see, 300 volts. Here we should find 5 volts. As you can see in the multimeter, we have 5 volts. Okay, so here we should find 16 volt. We have 16 volt in the multimeter. So here, as you can see, we have 5 volt in this capacitor. So let's check this capacitor, for example. We have 16 volt in this capacitor. So let's check this one also. We should find 5 volts. We have 5 volts. So here also, as you can see, I should find here. As you can see, we have here 3 volts. And this, in this pin, I should find 5 volts, as you can see. So 3 volts, 5 volts, the same 3 volts here, and 5 volts, okay, here. So also in these switches, you should find 5 volts. Here we have, let's check this one, we have 5 volts. So once you find the 5 volt voltages, means the voltage is good. If we go, for example, to the pin number 11 of this IC, we're gonna find 5 volts. We have 2 points. Normally, we should find 5 volts. Okay, it's working. Nice. The washing machine is working perfectly, as you can see. Nicely done. This is a complete course on how to repair any automatic washing machine, not just Whirlpool, LG, Samsung, Sony, etc. If you understand this course, if you follow with me and you stay with me until the end of the video, I'm guaranteed to you that you can fix any motherboard regardless of the problem it has, because I share with you a very important and exclusive information. Hi guys, welcome back to the second part on how to repair a Whirlpool washing machine from A to Z. Basically, this is the second part, the part number 2 and the final part. Okay, so guys, basically I buy a new, as you can see, multimeter. So this is a new multimeter that I buy. And this is basically the old one. As you can see here, this is the old one. So I buy this one. This is a very good multimeter for me. Okay. So basically, thank you very much for your support, for everyone who support me. So basically, I use that support that you support me to buy like this article for my channel. Now I buy a new multimeter. So in order to make more videos and a very valuable and informative video. And of course, guys, the more you support me, the more I will buy other stuff like the multimeter, oscilloscope, etc. And of course, I will improve my workshop and of course improve the quality of videos, etc. Thank you very much, and let's get started. So this is the motherboard that we have seen before, so in the part 1. So unfortunately, guys, I made a video, but I don't know why the video is not saved, because I make the videos just in my phone, not camera, just in the phone, and it's not saved. And in that video, as you can see, I made some troubleshooting, okay, and I find out that the problem for this motherboard is not the processor, not the diodes, not the power IC. The problem basically, guys, is here in this relay. Okay, the problem, guys, is in this relay. This relay, as you can see, we have here the inductor. As you can see here in the screen, okay, here we have the schematic for the relay. Do you see? Here we have inductor, okay, and here, as you can see, we have the switch, okay, but the inductor, guys, is not working. The inductor is cut. I will test it using the multimeter, and I will show you exactly why I use this. So I connect directly this point to this point, because the 220 volt or 230 volt doesn't pass here to this stage here. Okay, let's test first this inductor. Normally these two pins should be connected together, so let's check. Let's use our multimeter. Okay, so let's select the continuity option here. Really, guys, this multimeter, I like very much this multimeter because I use it about 3 or 4 years. 4 years I use this multimeter, okay, but it's okay because it is failed. I open it, I find that its processor is damaged, is burned out. That's why I cannot use it. Its processor is burned out. I can even make a video on how to repair like this multimeter, but I find that the processor is burned out, so it's best to buy another one like this one, especially to support me and to improve the quality of my videos. So here, as you can see, guys, I select the continuity option, as you can see here in the multimeter. Okay, so let's check, as I told you before, let's check this, as you can see here, inductor. Normally this inductor should give a continuity like this. So let's check one pin here and the other hand. Do you see, guys? Nothing. So inductor gives 422 in the multimeter. So if we swap, for example, to the resistors, so let's, for example, choose 2K ohm and see. So let's see again, guys. Do you see? We have 400 ohm. Okay, so 400 ohm, as you can see. We have 400 ohm. Means the coil is cut. That's why, guys, I connect this point to this point, as you can see. I connect this point to this point. Do you see? 0 ohm. Let's choose here to continuity. So I connect this point to this point. Means I connect here, as you can see, the input directly to here. Okay, now waiting for the relay. As you can see here, we have the relay, guys. This is the relay, the bad relay, as you can see. So let's see its reference, as you can see over here. So do you see the reference? Here we have SRTS-11-2D2-F-C1. So the schematic in the screen of this relay. So waiting for this relay, I just made this trick here to connect here these 2 points. Okay, now we're going to see the voltages. Before connecting this motherboard to the washing machine and check if the washing machine will work properly, let's first check the main voltages. I'm going to show you the necessary voltages that should be here in this motherboard. If you find these voltages, means you don't have problem with the voltages. I'm going to show you the secret. If you find all voltages in the motherboard, go directly and replace the CPU. Okay, if we find that all voltages are good, because we fixed the problem here, if we find that all voltages are good, and we install this to the washing machine and still the problem still persists, means the CPU is failed. We should replace it. And of course, I'm going to show you how to test the CPU right now using the multimeter. Basically, before going and checking the voltages of the motherboard, I'm going to show you right now the 3 methods that every technician, this is a secret, this is a trick that I use in a daily basis. 3 methods that you should use to test the ICs. Some technicians told me that the ICs, you cannot test the ICs, you should just replace it. No, you can't test it using 3 methods. The first method is by checking the heat of the IC using your finger. This is the simple and the basic method. If you find that the IC is very hot, automatically go and change it. Okay? The second method is by checking the ceramic capacitors around the IC. Do you see here? Here we have ceramic capacitors around the IC. Basically here in the ceramic capacitor we should find 5 volts. In this one also 5 volt. In this one also 5 volt. I'm going right now to check the voltage with you. Okay? So if you check the ceramic capacitors, if you find any shorted capacitor in both sides, means the IC is bad. Okay, so this is the second method. The third method, okay, is by checking the inputs and the outputs of the IC. For example, this IC, as you can see, always its VDD 5 volt is in the pin number 11. So here we have, as you can see here, a dot here. So here we have this dot, okay, means here we have the pin number 11. Why? Because we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. If we check the pin number 11, we should find 5 volt. I'm going to check right now the pin number 11. Remember, so let's connect right now the power adapter. Okay, so as you can see, already connected. Please guys, if you understand this course, this is a complete course on how to repair any automatic washing machine, not just Whirlpool, LG, Samsung, Sony, etc. If you understand this course, if you follow with me and you stay with me until the end of the video, I'm guaranteed to you that you can fix any motherboard regardless of the problem it has, because I share with you a very important and exclusive information. So let's test right now the voltages and then keep it going. So now the motherboard is powered on. So let's check voltages right now. So here this is the input. As you can see, if we check the input, we should find 220 volts, as you can see in the multimeter. Okay, so if we go, for example, and check this, as you can see, this is the VDR. This is the VDR. We have 220 volts. This is the capacitor. We have 220 volts. Okay, so if we put one probe here in the capacitor here and goes here, we have 220 volts. Okay, and in this point 220 volts. So basically this is the 23 ohm resistor here. So in one terminal we have 220 volt, in the other terminal we have 220 volt, means this resistor is good. So then we should, as you can see here, find 220 volt in the anodes of the diode. So in the other side, as you can see, oops, we don't have anything. Is that mean this diode is bad? No. Here we should select the continue voltage. We should go here, as you can see in the multimeter, we select the alternating voltage, as you can see 750 volt. We should go and select 1000 here, means the continue voltage, because after the diode we have to continue voltage, not alternating voltage. Okay, the same if we check, for example, As you can see here, the capacitor, normally we should find 300 volts. So let's check. So nothing, because we said select continue voltage. So let's select it. Pay attention. As you can see, we have here a high voltage. Please pay attention when you deal with motherboard like this one. Okay, so now we select the continue voltage. As you can see, now we should find, okay, 100% we should find here in the diode and in the capacitor 300 volt DC. So let's put always, as you can see here, one probe here and check this side. We have 300, as you can see. Anyway, if we check the capacitor also, we should find, as you can see, 300 volts. Okay, I have problem with the multimeter maybe. The problem is with the multimeter, because that minus should not be there. Okay, so we have 300. Okay, we have 300. The problem is with the multimeter. Guys, we have problem with the new multimeter. Let's make it off and then on. Go. Good. So let's choose. You can see it. You can choose. Okay. We hope that our multimeter work fine. So okay, now let's check here. We should find 300. Okay, but minus, I don't know why minus. Anyway, we have 300. Good. So let's switch on our motherboard. Okay. Oh yes. So as you can see, the LED comes on. Now I'm going to show you how to test other voltages. Now we test the primary stage where we have the high voltage. Now we're going to check, as you can see, the secondary stage where we have, as you can see, the processor, the switches, etc. So now let's go and select 20 volt. We're gonna select 20 volt because we're gonna measure just the low voltages like 2 volts, 5 volt, etc. Okay, so let's check right now. Here, let's begin with this regulator. Here we should find 5 volts. As you can see in the multimeter, we have 5 volts. Okay, so here we should find 16 volt. We have 16 volt in the multimeter. Okay, if we go here to the processor, so let's pick any ground here. For example, here we have the ground. Okay, and check, for example, this capacitor, we should find 5 volts. Okay, let's check this capacitor. So here, as you can see, we have 5 volt in this capacitor. You see 5 volt. Also, let's check this capacitor. So let's check this capacitor, for example. We have 16 volt in this capacitor. So let's check this one also. We should find 5 volts or 16 volts anyway. We have 5 volt. So 5 volt here in this capacitor. Also here, as you can see, we have 16 volt, and in this capacitor you should find 5 volts. So 5 volt is here. So here also, as you can see, I should find here, as you can see, we have here 3 volt, and this in this pin I should find 5 volt, as you can see. So 3 volts, 5 volts, the same 3 volt here and 5 volt, okay, here. So also in these switches you should find 5 volt. Here we have, let's check this one, we have 5 volt. So once you find the 5 volt voltages, means the voltage is good. If we go, for example, to the pin number 11 of this IC, we're gonna find 5 volts. we have 2 points. Normally we should find 5 volts. So the voltages in this motherboard is good. So let's connect the motherboard and see whether the washing machine will work properly or not. So now we're gonna test the washing machine. So I connect the motherboard. As you can see here, the motherboard is connected. So I put it here just in case. Okay, here we have the motherboard is connected. We have all cables, as you can see here, are connected. I connect, as you can see here, the inlet. This is the inlet of water, and here we have the exhaust. All is connected. So let's plug the power adapter. Okay, so let's plug the power adapter. So once the power adapter is plugged, let's select. Here we have the selector. Okay, so this selector now is not working because the motherboard is not installed, but we have here the selector. So let's select, for example, here we have the LED. So it's okay. Good. It seems to be working. Nice. So here I'm going to push the on-off button. As you can see, the on-off button is eliminated. So let's see here. Here we have the water. As you can see, good. So it's okay. Let's see here. Okay, it's still on. The water, as you can see here, is okay. Now let's see. Okay, it's working. Nice. The washing machine is working perfectly, as you can see. Okay, nicely done. So the only problem that we have is this, as you can see, the rolly, as you can see here. So the problem is here. So the motherboard is fixed 100%. So the only problem in the motherboard of this Whirlpool washing machine is the rolly, the input rolly. The coil or the inductor in the rolly is cut. Okay, as we have seen using the multimeter, no continuity, no buzzer. So I just use a wire. Okay, just a wire until I receive a new rolly, and I will of course replace it.